This is TechSNAP, episode 381. Hi, everyone, and welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on August 29th, 2018. It's brought to you by our three great sponsors, iXsystems, DigitalOcean, and Ting. Tell you more about them in just a bit. My name is Chris, and joining me every single week is my co-presenter, the teacher, the admin, and the engineer. It's Mr. Payne, Mr. Wes Payne.
Hello, Chris.
Hello, Wes. We're going to warm up this week with a story that may change DNS on the web. And it's something that both Mozilla and Google are pushing pretty hard. And Mozilla argues that browser users are currently experiencing spying and spoofing of their DNS information due to reliance on the unsecured traditional DNS protocol. There's a paper from the 2018 Usenet Security Symposium that provides a new data point on how often DNS is actively being interfered with. And that's to say nothing of just passive data collection around DNS queries. So that's where DNS over HTTPS, or DOH as it's called, comes in.
DNS over HTTPS is a method for securing DNS requests that relies on the security practices we've already built for TLS on the web. That's HTTPS. Now, in thinking about this, Mozilla is really concerned with a couple things. First, that you could end up using an untrustworthy resolver that tracks your requests or tampers with responses that you received from upstream DNS servers. And this is thinking about the traditional model of DNS, right? Where you have system resolvers set up. You might even have a DNS cache on your local network. But whatever happens, you send a DNS request, it goes to the immediate resolver that's assigned to you, usually by DHCP, and then that goes up and recurses up through several layers of resolver until it finds a DNS server that can either answer it or just keeps referring it until it eventually gets to the root zone. One of the problems here is that there's kind of a lot of information. In many cases, the IP address, or at least parts of the IP address, are included in these DNS requests, something along the lines of, hey, this guy is looking for the address for this site. That's a lot of information. And so if you have possibly a large number of DNS servers that a request may go through, that's a lot of opportunity for information capture. In that same way, between all of those recursive resolvers, you're also just going through a lot of regular internet equipment. So it may be that you find some on-path routers that are messing with your requests. And of course, whoever's running all those servers really can just do whatever they like with the information that they've stored. To address these concerns, Mozilla is trying three things. First, trying to just avoid what they label as untrustworthy resolvers by using a system they call Trusted Recursive Resolver. Secondly, they want to protect against those on-path eavesdroppers and prevent tampering using DNS over HTTPS, and that's where you're just sending DNS over an HTTPS connection, which you already have shown to be secure. And finally, design this in a way that you can transmit as little data as possible. That way there's just less information for anyone to work with.
That sounds pretty interesting. So what's the current status of DNS over HTTPS?
Right now, the main document everyone's referencing is a draft put out by the Internet Engineering Task Force. There's been several client and server implementations out there, some preliminary support in some of the tools near you, and that's what Firefox and Cloudflare have been using to implement their recent DNS over HTTPS experiment.
Oh, an experiment, you say? So what has Mozilla been trying?
They've conducted a study using about 25,000 Firefox nightly users who had previously agreed to be part of various nightly experiments. They're really asking two technical questions with this, which is one, does the use of what they call a cloud DNS service perform well, and does it perform well enough to replace traditional DNS? And secondly, does the use of a cloud DNS service create additional connection errors, right? So even if they are working, are we seeing a lot higher error rates? In this case, Mozilla partnered with Cloudflare. That drew up a lot of concerns from some parties on the internet. They explain a little bit more about why they thought that was a good idea. Cloudflare operated those servers, and they operated them according to a privacy policy that they agreed to with Mozilla. Each user was additionally given information directly in the browser about the project, and that information included the service provider and an opportunity to decline participation in the study. So Mozilla clearly feels that they've done a decent job of informing users that we're making this change, you're included in it, some of your information will be accessible by a third party, in this case, Cloudflare.
So to be clear, Cloudflare is acting as a type of DNS over HTTPS proxy or middleman, so it has to have some sort of service in between?
Yes, and that's how this works. One of the things they've identified is, sure, you might trust your local ISP's resolver or the DNS mask cache you've set up at home, but when you're in the coffee shop, if you don't take any particular measures, well, you're going to use whatever the coffee shop Wi-Fi tells you to use, and they might, they could do all sorts of things, send you to strange sites. If you, you're especially vulnerable if you're visiting a site that doesn't have HTTPS, and you can just, DNS spoofed, away you go.
And I guess one more point of clarification. I guess this means the web browser is using its own DNS settings regardless of whatever the operating system is configured to use.
Yes, that's where the trusted recursive resolver comes in. And basically the browser is picking a trusted resolver that it's going to use to send all of its DNS requests. It just happens to also do that in this scheme by sending them over HTTPS. And those two act together to try to combat the flaws that Mozilla is identifying.
I find it kind of interesting that for this particular study, Mozilla had a individual privacy policy carved out for Cloudflare that supersedes the company's privacy policy. So I guess they must have run this for a while. Some of these nightly users were sending their DNS requests through Cloudflare. Did they get some useful data?
It's at least interesting. They saw only a minor performance impact on the majority of non-cache DNS queries as compared to traditional DNS. And that was around 6 milliseconds slower. And a lot of that's just, HTTPS is a more complicated protocol and you're adding encryption on top of that. So, there's negotiations, all those sorts of things. 6 milliseconds, well, it's not bad. Interestingly, though, the slowest DNS transactions performed much better with the new DNS over HTTPS based system than the traditional one. Sometimes hundreds of milliseconds better. So these are like the worst case, slowest DNS requests, and the distribution of those just looked a lot better on the new system. Really what they saw was that the slowest 20% or so of DNS exchanges were just radically improved, while the majority of exchanges had just a small, mostly tolerable amount of overhead. They say, and in their mind, this is a good result.
So it kind of sounds like in some cases it was slower for a few people, but for other people it was faster. I guess this really is sort of like a typical cloud service, depending on your connection to the cloud service. Yeah,
that's one thing about this, that it's not, in many ways, it's just simpler in that you're talking to less servers. Now, Cloudflare may have to go back and query some servers on its own end to get final results, but you're just talking to the Cloudflare server. Because of that, Mozilla hypothesizes that some of the improvements they've seen could have been because, well, one, the consistency of the service is just better. Cloudflare runs professionally maintained servers already. They know what they're doing. And it's just less servers that you're talking to instead of who knows what number of random ISP or other middlemen servers that are being run as your DNS resolvers. I'm not sure the coffee shop updates the firmware on their routers that often. And secondly, HTTP is just a more modern protocol than the traditional DNS protocol. It's seen a lot more updates and is used for a lot of performance-sensitive things. So it has better loss recovery and congestion control built into it and can do better on some of those really lousy networks that you see for those low-end requests.
I'll be honest, it does sort of set off alarm bells in my head to send all this stuff through Cloudflare. But then I started thinking about it. What do I really know about the traditional DNS providers that I've been using for years? Nothing. For all I know, they're collecting all the information on me. It's really just sort of a transition of trust, where I place my trust. And something tells me that Mozilla could widen the circle of trusted providers that come baked into the browser.
Right. You could imagine a future where there are a number of organizations, perhaps some that are nonprofits or other parties that you might have more trust with, that you could choose between in some settings menu somewhere, or maybe even supply your own value if for some reason you wanted to run your own such server.
Well, assuming you could alter where you send your DNS over HTTPS request to, there is a DNS over HTTPS server we've seen pop up online that people could self-host.
Yeah, this handy project has both a client and server implementation, and it looks like they've got it for both Google's own variant, which is more of a JSON response over HTTPS, and the IETF draft that we've been talking about and that Mozilla has been implementing, which is really just the regular DNS wire protocol shoved over an HTTPS pipe. It's written in Go, so it should be pretty easy to get started with, and by default, it's using Google's DNS, so go play with it. Let us know what you think.
Apache Struts is a well-known enterprise-grade Java MVC framework. We've talked about it in previous TechSNAPs as it was at the core of a rather famous breach that involved Equifax where they started blaming open source ages ago. And it's back in the news this week.
For more background, check out TechSNAP 338. Today, the vulnerability in question is CVE 2018-11-776, a remote code execution flaw that allows an attacker to gain control over any Struts-based web application. Now, thankfully, it's not exploitable in the default Struts configuration, but it's still a big deal just because Struts is used so widely in some of the world's largest enterprises. To make matters just a bit simpler and maybe worse, over the course of the past few weeks, several security researchers have put together different proof-of-concept scripts, and that includes a step-by-step tutorial. Really, it couldn't be easier to construct a working exploit for this. You just need a free afternoon.
I like that they have step-by-steps ready to go. Hey, just, make it easy for everybody.
I mean, yeah, one of them's been embedded into an all-in-one Struts exploitation toolkit.
So if there's all of these easy-to-use tutorials and guides, are we starting to see this sucker in the wild?
We sure are. According to Matthew Meltzer, a security analyst for Velexity, they've been seeing a wide geographically distributed attack on their network of honeypot servers.
So they set up some boxes running this Apache Strut software that's vulnerable and started getting folks knocking on the door.
Exactly. Unfortunately, they have not been able to pinpoint the exact nature or group responsible for these attacks, but they have seen that they break in through the Struts vulnerability and then contaminate the underlying server with a version of the CNRig cryptocurrency miner downloaded from a Bitbucket repository.
Crypto miner. There it is. We had to get one mention in this week.
It's TechSNAP policy. Now, right now, the attacks are still small in scale, especially compared to some other major actors out there on the internet. But with it being so widely deployed and so easy to exploit, I'm sure we'll be seeing a lot more news about Struts.
Shifting gears for a moment, on Monday, Twitter user Sandbox Escaper published news of a zero-day vulnerability in Windows 10 via a rather ranty-type Twitter post, while also releasing some proof of concept to just go right along with the bug.
The researcher found a local privilege escalation vulnerability in the Advanced Local Procedure Call, or ALPC, interface of the Windows Task Scheduler that could allow a local user to obtain system-level privileges.
Wow. And CERT has confirmed that the bug does work on both 64-bit versions of Windows 10 and Windows Server 2016. The bug could also be exploited on other versions of Windows with a few modifications.
Unfortunately, they didn't identify any easy workarounds besides just waiting until Microsoft has a patch.
Which Microsoft kind of implied that they may have a fix in the next update that ships on Tuesday, September 11th, 2018. Maybe.
Watch your networks, everybody.
Now, I mentioned that the tweet was a little ranty. It seems that they had some bad experiences trying to submit this bug, or maybe like another bug, a previous bug, not quite clear, to Microsoft, which just led this time the researchers to take to Twitter and just publicly disclose it.
It also seemed like they've been trying to sell this bug maybe a little bit in the past. Someone with a similar handle posted several times on Reddit asking how to sell Windows zero-day bugs, and they'd also mentioned on Twitter that they couldn't wait to sell bugs in Microsoft software.
So obviously, a classy guy.
That is one of the dangers of this field. Even sometimes well-meaning security researchers, you spend a lot of time working on these hacks. You try to communicate them, and if it's not received well, that can really dishearten you, but you've still got the skills. Unfortunately, there's just a lot of gray areas here, and I think that makes it even more important. Now, Microsoft in the past has done a reasonable job of responding to vulnerability requests pretty quickly. I'm not sure what's going on this time.
do.co/snap. That's where you go to get a $100 credit over at DigitalOcean, which is infrastructure under your control on demand. You can get started in less than 55 seconds and have an entire system deployed. Everything's using enterprise-grade SSDs, 40 gigabit connections coming into the hypervisor. They use these systems that would blow you away in terms of performance. Go try it out. You can get a $100 credit and kick the tires for 60 days for free when you sign up with a new account. Just go to do.co/snap. Industry-leading price to performance, predictable and straightforward billing, and it's trusted by over 1 million developers. It's the easiest cloud platform to deploy, manage, and scale applications, but that doesn't mean it doesn't have power tools. Those of you who've been deploying servers and managing virtual systems for ages will find yourselves right at home. And if you've never set up a server before, their control panel makes it all very easy. Don't call it a control panel, call it a dashboard. See what I've been talking about. Go to DigitalOcean, do.co/snap. And a big thank you to Ting. Why Ting? Because it's smarter than unlimited. You go to TechSNAP.ting.com. You'll get a $25 credit off a device or in service. And you pay for what you use with Ting. So that $25 will get you far. It's a fair price for however much you talk, text, and data you use. And they've got you covered with nationwide coverage, CDMA, and GSM networks. And there's no contracts, no service agreements, or anything kind of awkward. You just pay for what you use. It's $6 a month for the line. And you happily use it. They have a control panel. When you're done happily using it, you could turn it off. You could add another device. You could manage individual aspects of your account. And if you ever get stuck, they have the best customer service in the business. You can see your usage at a glance using their app or their website. You can take complete control at any time. You can set usage alerts, which is great for those kids. You know what I'm talking about. And you can buy a device directly from Ting, or you can bring one. And with CDMA and GSM, there's tons of compatible devices. My first Ting device was an Evo 4G WiMAX that I activated through their website at like 1 a.m. over 4 years ago. And I have been hooked ever since. Nobody does it like Ting. From the simple pricing, the fanatical customer service, and the easy-to-use dashboard that lets you turn devices on or off or set up individual services, it makes it so easy for somebody like me to have a couple of MiFis. I pay $6 for each of them, and I'm always ready to go with emergency backup data. That peace of mind is worth the $6 a month for me alone. Try it out. Go to techsnap.ting.com. And a huge thank you to iXsystems.com/TechSNAP, the only server hardware provider we recommend, and that is based on our personal experience. iX will work with you, a white glove approach to custom build a solution. And I know you've been thinking about improving that backup system. Well, look at what iX has to offer. Not only do they have fantastic hardware, but they'll also match it with great open source software. And of course, they're the folks behind the TrueNAS storage appliance. And as your data continues to grow, preserving it is more demanding than ever. You can protect your enterprise storage environment and save time and money with a TrueNAS unified storage array. With built-in data security from OpenZFS, which we all know and love, it has industry-standard built-in data encryption that's compliant with HIPAA, PCDSS, GDPR, and it's really the enterprise-grade version of FreeNAS, which we've talked about for ages. You can achieve better backup integrity through self-healing bit rot mitigation, unlimited instant snapshots, replication, encryption, and more. And if you ever get stuck, they back it up with their award-winning white glove US-based support. That's iXsystems in a snapshot. They'll build a perfect solution for your environment that will run reliably and have a white glove experience around the entire thing. I encourage you to start the process. Go to iXsystems.com/TechSNAP. You've tried fighting with all of the other hardware providers. Now it's time to do it right. iXsystems.com/TechSNAP.
Thank you so much for going to techsnap.systems/contact to send us your feedback, war stories, or your favorite tools.
Like Mike did. Mike writes in and says, hey guys, so for just a few systems, I really like NetData. You can see some of their live demos at my-netdata.io. It's really great, and it can be connected to larger metrics collectors such as Grafana. I hope you like it. Check it out. NetData. I actually have checked it out. I love NetData. It is beautiful. It is great. Like Mike said, if you have 3 or 4 systems that you want to get data on, and it is really easy to get set up and started.
Yeah, NetData is absolutely one of my favorites. Really, I just want all of my machines to have it. And Mike's absolutely right. It's really easy. They've got Prometheus support, Graphite support. There's a ton of different backends. So if you already have a larger metrics gathering system, let NetData be your on-machine collector. It comes with a great web interface that's actually written with performance in mind, so you don't have to worry about it taxing your system. I'll also note that the creator of NetData is also responsible for Firehole, which is one of my favorite Linux IP tables-based firewall configuration languages.
Oh, interesting. And then kind of on the other end, if you're just on a single box and you want to get an idea of how your disk I/O subsystem is performing, or your network I/O subsystem, or your CPU cores, I love the simple command dstat. It's one word, dstat. You probably have it in your package repository, and you install that. It just creates a new line of data so you can see historical trends and things like that. It's a beautiful little app that just gives you some quick metrics on the box that you're SSH into or whatever. And it's DStat, and it's free.
There's just too many great Unix tools these days, so if we've missed something, please let us know. TechSNAP.systems/contact, or hey, we love war stories.
Well, that brings us to the end of this week's program. Links to everything we've talked about, TechSNAP.systems/381. And a final thought for the show today, you often will hear us say, patch your shit. Everyone always yells, go patch ASAP. The computer industry itself has moved to a more frequent software security updates from Microsoft and from other vendors, and more regular updates as well. But the rest of the world still takes a month or longer to patch their networks.
This is all according to a new report that spoke to 260 IT heads in both the UK and the US and has some, well, potentially eyebrow-raising results.
Yeah, it says that more than a third of IT managers, 37%, view the slow installation of software updates as their biggest security threat they face. Even more than an idiot end user choosing bad passwords, which was ranked at 33%.
And that's for a good reason. The survey revealed that nearly half, 45%, of large businesses take at least a month or more to patch their networks. And worse than that, just over a quarter take several months.
And my experience has been years, really. When I go into places, I have seen systems unpatched for years. It's a security nightmare waiting to happen. We all know it. And it's been made clear by this research and by the stories we covered today about Apache Struts 2. Roughly half of Fortune 100 companies use Struts for their web apps, and Apache warned them to update immediately. But yet we saw a big hole in that framework used to exploit Equifax because they simply failed to patch fast enough.
Where do we go from here? Well, I think there's probably a couple things we could start doing better. Firstly, things just need to be designed with updating in mind. Vendors need to ship small, manageable updates that build trust with the people using their software. And on the other side, enterprises and all end users need to actually enable updates and do so in a timely manner, automatic, or at least in a way where you're doing them on a regular cadence. Of course, that comes with, building infrastructure to do that. Maybe you don't want those in your production network, but that means it's on you to build a QA system where you test that, and then once finished testing, push that into production as soon as you can.
Right. Create the expectation with your infrastructure that there will be outages to accommodate security patches. It's part of the system, and it's easier said than done. I acknowledge that. But anytime you get an opportunity to build with that mindset, you're going to be in a position where you can respond faster with these security updates.
I think it's also important for the business to understand that, and maybe for our community and culture to make it so that it's more costly not to perform these updates. If we value this information and the leaks and the damage exposed by it, then at some point it just makes more sense for businesses to view security as an essential part.
Yeah, I completely agree. And there's things that the OS vendors and software vendors could do to make the patching a little safer. And there's processes and procedures that could be implemented on the admin side to make things a little easier. But I think it's something that we all know has been a problem for a long time, but it does feel like there are things on the horizon that are actually going to help address this. You have things like the design of CoreOS or Fedora Atomic and other read-only type file systems where there's an A/B transactional style update that make updates much safer to apply. And the more we see adoption of that, the more we'll see this problem solved.
Really, we have the ways to address these problems. We just have to make it a real effort.
Yeah, and it's finally happening. And we'd love to know your thoughts on this, TechSNAP.systems/contact. And that'll bring us to the end of this program. If you'd like more Wes, check him out on Linux Unplugged. He's at Wes Payne. I'm at Chris LAS.
You can find all those juicy links you'll be wanting for this episode at TechSNAP.systems/381. And if you want to make sure that you get all the latest TechSnaps hot off the presses, that's TechSNAP.systems/subscribe.
Thanks so much for tuning in this week's episode of the TechSNAP Show, and we'll see you right back here
next week.